So before we launch into this, just remember what we're doing with the geometric. We're doing a series of Bernoulli trials, which means we have two outcomes, which we call success or failure. And what we do is repeat the trials until we get a success. If we consider that each Bernoulli trial has a probability P of success, this has to be a fixed probability of success, otherwise our analysis won't work. We can consider Q, which is 1 take away P, to be the probability of failure. Let's define X as the random variable, the number of failures before we get the first success. Then, the probability that X is equal to X is equal to Q to the power X times P. In other words, Q to the X gives us the probability of this happening. In this case, there's 4 failures. So that would be Q to the 4, or 1 minus P to the 4. And then, of course, we get the probability of success at the end, and that's the P just here. And X has to belong to the natural numbers in union with 0. So in other words, that is the set 0, 1, 2, and so on. So in actual fact here, we're considering X to be the number of failures. So if we look at this one here, we would be saying that X is equal to 4 because we had 4 failures and then we got the success. But the probability of X being 4 would be the Q to the 4 times P, because of course we don't terminate until we get that success. Now that's slightly different, I think, to what I said in introduction 1. I did say that there were 2 different versions. There's a different way of defining the random variable so that X would be 5. In other words, it would be the total number of times you perform Bernoulli trials. So we're not doing that one here. Looks like we're doing this one. It can be shown the derivation uses the sum to n terms of a geometric series, that the expectation of X is Q over 1 minus Q, and that is equal to 1 minus P over P, the last step being trivial because, of course, Q is 1 minus P. We can, of course, define var x, or we can find expressions for var x and SD of x, but I'm not going to go into that here because, as I mentioned before, this particular distribution, the geometric, is not specifically on the syllabus.